Again, Mr. Wakefield here, looking at section 5.3 right now. Very similar to the last video and the last section, which was 5.2 right here. And what it is it's where it says solve, and then it gives you two linear equations with two variables in it. That's what it means to solve what we call a system of linear equations, a system of linear equations. And we're going to solve them. I'm going to solve that system anyway. And what happens is that when you try to solve that system, you're usually going to get an answer where you have an x and a y, and that's why we put it together as an ordered pair right here. Usually that's how the answer comes out. But every once in a while, when we solve one of these systems, the variables disappear while you're in the process, as you can see here in problem C from the last section. The variables disappear while you're in the process of solving, and when that happens, you will either get this fancy looking answer if the resulting statement is true after you get the variables to disappear. But if the answer had been false, and I'll show you an example of that once again from 5.2 as well on right here. If the variables disappear and then the resulting statement is false, we then just say no solution. So there are three different possibilities. If the variables disappear, okay, and you get a false statement, it's no solution. If the variables disappear and you get a true statement, you get this type of answer here, all right, which we talked about in the last video. But usually, and this happens when the variables do not disappear. If the variables do not disappear, you will always get, when you solve one of these systems, this type of answer where you have one x value and one y value, and you just pair it up like this as an ordered pair. Okay, so in this current section that we're about ready to look at, all of those results will be the same. Okay, you will either get a answer where you just have an ordered pair, like I said, or you'll have one of those other two possibilities where the variables disappear and you'll either get a true or false statement. All right. So we have a total of three possibilities that we learned about in the last section, in section 5.2. Those same three results are going to occur here, but the only difference is the method that you use to get to whichever one of those three results takes place. Whichever result that is, we're going to get to it by a different method here in this section. But again, the three results will still be, those three results are the only three possible results that you'll get. Okay, we're just going to have a different route to get there now. So let's learn about this different method here. We do need to know both methods, this method here, the elimination method, and the method that was in the last video, the substitution method. There will be at least one question on the upcoming exam, okay, where you have to use the elimination method. It will say that you have to use it on that problem. And then there will be at least one question on the upcoming exam where you must use what? Where you must use the substitution method, and it'll say that in the directions. Okay, so there'll be no confusion. But make sure you're reading the directions. I know sometimes when we're taking a test, we can be in a real hurry, and we can kind of be careless about the directions. Make sure you're reading those, okay, carefully. So anyway, let's talk about now how to do the elimination method. So what we have here is we have 6 steps here. Okay, the first step is usually done already. It says write the equation with the variable terms on one side of the equation. In other words, on one side of the equal sign, and constants, meaning terms that don't have variables in them, on the other. Okay, so you can see here that that's the case here. You have the x's and y's on this side of the equal sign, and then on the left side of the equal sign. And then you have the terms that don't have the variables in it on the other side of the equal sign. That's exactly what we want. In particular, we want the x's to line up and the y's to line up. That's not required, but it is easier to have them line up like that. You can see in the next problem here that the x's and the y term is not with the x term. We're going to want to move that y term over. That's what the first step at the top of the page is trying to tell us to do. Okay, again, you want the variables on one side and the terms that don't have the variables in it on the other, like we have here with the 3 and the -1. So once that step is confirmed, all right, here's the key step. It says multiply either one or sometimes both equations. We'll talk about which one of those two things you got to do, either one equation or both, as we go along here. But you got to multiply by appropriate numbers, and sometimes it's not necessary, but usually it is, so that the coefficients of either x or y, doesn't have to be both, either x or y are opposites of each other. What does the word opposite usually mean in math, and what does it mean here? It means that you have the same number but opposite sign. So for example, -6 is the opposite of 6. -8 is the opposite of 8. But 9 is the opposite of -9. Okay, same number, opposite sign. So for example here, let's say, look at this problem right here. You're looking at this, and what your goal is, and again, you don't have to do it for both variables, all right? Just pick a variable and say to yourself, okay, the 7 is bigger than the 3, right? So look at the bigger number, and I'm looking at that right here. And I then ask myself, how can I make the 3 so that it's equal to -7, so that it'll be the opposite of 7? But you have to multiply. And so what you need to ask yourself is, how can I multiply by 3 so that it's equal to -7? Well, that's not very easy, is it? Okay, you'd have to multiply by a fraction, wouldn't you? Okay. In fact, you don't have to write this down because we're not going to do it. There's an easier way, as it turns out. But you'd have to multiply 3 times -7/3 here, okay, in order to make it equal to -7. All right, because then the 3's would cancel and you get -7. But believe me, you guys, you don't want to do fractions here in the problem if you don't have to. Okay, like we said in the last worksheet when we did the substitution method, you want to try to avoid fractions if you can. Sometimes you can't. Usually you can, though, thankfully. And so I'm going to, because I told you just a minute ago that you could do either x or y right here, let's go ahead and try y now and see if we can avoid a fraction there. Okay, so I'll cross this out. See how 6 is the bigger number, just like 7 was here? 6 is the bigger number. So then you look at the smaller number for y and you say, okay, could I multiply 2 by something so that it's equal to the opposite of 6, which would be -6? Okay. 2 times what is equal to -6, you guys? Well, that one is not going to be a fraction, right? 2 times -3 is -6, so that's going to work out nice. No fractions there. And so that's what we're going to do. We are going to take... In fact, you don't have to write this part down, but just so I can communicate with you, I'm going to say -3 times the second equation, okay, because you have to multiply by the entire equation once you figure out what you're going to multiply by. And then you're going to add that to the first equation. All right? Notice that I'm not multiplying the first equation by anything here. I'm multiplying the second one by -3. And we're going to add it together after I multiply. Got to multiply first. Okay, so how do you multiply an equation by something? What do I mean by that? What I mean is that if you just have a polynomial on both sides of the equation here, like you can see that we do, and there's no parentheses or anything, what that means is to put a bracket around both sides of the equation like this, and then distribute the -3 to each term if there's more than one term on a particular side of the equal sign. Okay, like this. So I'm going to distribute that through. Okay, and then if there's just a single term on the other side, you just multiply. You don't distribute when you're multiplying by a single term. It's just when you have more than one term with a plus or minus in between it, like we do here. So what would happen if I distribute the -3 to these two terms? I would get... And I'm going to leave some space here because I want to keep this first equation the same. I'm going to put it on top of it here. But I get what here? I get -9x minus 6y. Keep the equal sign where it's at right there. Just bring it straight down here. And then -1 times -3 is 3. Okay? And so you're just simply multiplying the -3. You're distributing it to every term here on both sides. keeping the equal sign where it's at, though. So if there's two terms on one side, you distribute it to that like you normally would when you distribute through a parenthesis. Okay, make sure there's a plus or minus in between the two answers you get. Since 6y was negative, we put a minus there in between the two answers when we distribute. And then on the other side, you're usually just going to have one term, so you just multiply by that. Okay. Now, the first equation, like I said, stayed the same, so let me just bring that down. We didn't need to multiply that by anything. Remember, our goal, you guys, is what? Our goal is to make either x or y opposites of each other, and we did it, okay? 6 and negative 6, those are opposites of each other, so the y terms are opposites of each other. So then, according to my thing here where I said plus, that means I'm now going to add the equations together. And that's exactly what it says up here in step 3. It says add the two equations. Now, when I first was a student learning this stuff, I thought to myself, what does it mean to add equations? That seems kind of weird because they're equations, right? They got equal signs. What does that mean? What it means when you add the equations is it means to add the left sides together and add the right sides together, okay? And since these are a couple of polynomials here, when you add polynomials together, you just combine like terms. But what happens when we combine like terms right here is that because these are opposites of each other, they cancel out. We know that when you're combining like terms and you have opposites, they cancel. We've done that many times before, right? Okay, where they've canceled like that because when they're opposites like that. These combine together to be negative 2x, though, don't they? So I'll bring that down. Bring the equal sign straight down. And then add together the right-hand sides. 3 plus 3 is 6. And so what this does, just like in the last section, you guys, what it does is it creates an equation with only one variable in it. All right, remember when we did the substitution method, and I'll pull it back up here for just a moment. When we did the substitution method, we eventually created an equation with only one variable in it. It was a totally different method that we had to do in order to get to that point in the problem, but we did create an equation with one variable. Same thing here, we created an equation with one variable. It was just a totally different method that we had to use to get there. We had to add the equations, right? So now that I have that one variable equation, just like in the last section with the substitution method, I now solve that resulting one variable equation. All right, since you just have a variable term and a constant term, one on each side here, that's that step where you divide out, right? Okay, we've done that many times with linear equations before. And so just like the last section, you're not going to see any quadratic equations here if you do this right. It should always be a linear equation after you add the equations together. And so you just do the linear steps. And since you are already on the last step of the linear equations where you have a single variable term and a single constant term, one on each side, and that's all you have, that's the division step, the last step of the linear equation problems. So we get what? We get negative 3, don't we? Again, just like in the last section here, after you figure out what one of the variables is equal to, okay, it doesn't have to always be x, it could be y that comes first sometimes, but what you do is you go back and you plug it back in to figure out what the other variable is. You do it a little bit differently in the elimination method, but it's the same idea. What you do in the elimination method is that you go back to one of the original equations. It actually could be any equation in the whole problem as long as it has both variables in it. Okay, but I usually just tell students to just pick one of the original ones. But you got to take this number and plug it back into any equation that has both variables in it. I'll go ahead and pick this one. All right, that'll be fine. And remember, this is x, so you got to plug it into the x up there. You got to plug it into the x. All right. And it's kind of like when we were graphing lines at the beginning of chapter 4. When you plug a number into a polynomial equation where you have polynomials on both sides, all right, the term that you plugged into, figure out what that's equal to first. And then it'll look like a normal equation and you should be able to solve it, okay, because you've solved the linear equations many times before. So what is that term, the 7x term, what is that equal to when I plug in the negative 3? It's equal to negative 21, right? All right. Now it looks like a normal equation. Okay, now that I figured out what that term was equal to, negative 21. So now I just solved that. Since it's a linear equation, it appears that we are now on that step where you have to move the 21 and the 3 on the opposite side of where the 6y is, right? Okay, there's no parentheses to get rid of, no like terms to combine. In other words, we're on that step where you got to move those terms to the opposite side of where the y term is. And then now we're on that step where we got to divide out to get the y by itself. And we did it. So just like in the last section when we did the substitution method, okay, you figure out what one variable it is, you figure out what one of the variables is, you then plug it in to figure out the other one, and then you get your ordered pair. Same thing here. All right, so we figured out x and y, and so our final answer is going to be putting those two numbers together, all right, and I'll put it down here, -3, 4. Remember, the x always comes first when you make the ordered pair. And so there's your final answer right there, just like we had on the first problem of the substitution video. Okay, you got an ordered pair. And you will always get a single ordered pair in these problems unless the variables disappear, like we talked about. Okay, let's move on to the next problem. All right, as I mentioned, in the first step of the elimination method, you have to get the variable terms on the same side. Assuming that you have a polynomial on both sides with no parentheses, you can see we got a single term here and two terms separated by plus here, so they're polynomials on both sides. When that happens, if you want to move a term completely, not just part of it, but the entire term over, the way you do that is by adding or subtracting it over. And so that means I need to subtract the 2y over with the 12x. Because it's positive 2y, I want to subtract it, right? Okay, so we're going to get what here? We're going to get, let me just set it up here. So I subtract the 2y over, and it's going to look like this. Put the x term first, okay? It's not completely mandatory, but if you do that, it'll allow you to have it line up with these ones because the x comes first here. Again, it's going to be easier when you do that step over here where you combine like terms. It's going to be easier to do that step when the terms line up according to their variable. So x and x, y and y, all right? And then the terms that don't have the variable in it on the other side. So this is what our system is now. I just rewrote it so that the variables were on the same side. X's line up, Y's line up, and then the terms, the constant terms on the other side without the variables, okay? Now, what's that next step? According to the top of the page, the next step is that step where you multiply, okay, one or both equations, all right? Here's the thing. Remember in the last problem I said start out by looking at x, okay, and see if that works. If x doesn't work, then you could try y. And what you do is you look at the bigger number, okay. 12 obviously is the bigger number, and so then you ask yourself, what can I multiply 8 by in order to get 8 to become -12? So it'll be the opposite of 12, so that it'll cancel like these cancel. Well, you can't do that very easily without multiplying by a fraction, right? You'd have to multiply by a fraction or decimal, not a whole number, in order to get it to equal -12 right here. All right, you want to be able to multiply by a whole number or a negative whole number like -3 in order to avoid fractions or decimals that make things a lot more complicated, okay? And you will always be able to in these problems when you do this step. All right, that's the great part about it. All right, but I need you to listen closely here so you'll know how to always be able to avoid fractions. All right. So the x's is not going to work. So then we go over here and we say, okay, irregardless of sign here, all right, I'm not ignoring the sign, but the 5 is bigger than the 2, right? Okay. But so irregardless of sign, 5 is bigger than 2. And so what you do when that happens is you look at the -2 and you say, okay, what could I multiply that by so that it will be equal to +5 so that it'll be the opposite of this? Well, bad news again here. You can't multiply -2 by something to get it equal to 5 unless you multiply by a fraction or decimal, okay? So that is that's the thing, you guys. I tried both variables. Neither one of them are going to be able to avoid fractions. But there's good news. It says up here in the second step that sometimes you can multiply by both equations. Let me show you how to do that. Okay, so if you can't do x by itself or y by itself, all right, you can't multiply one of the equations by something. If you can't multiply the smaller number by something so that it's equal to the opposite of the other equation's number, then what you do is this. And again, you could pick either variable when you do this thing I'm about to show you. Okay, so if neither x nor y works, here's what I want you to do. Go ahead and I'll pick x this time, but you could pick y. All right. But what you do is you take the 12 and the 8 and you flip them off to the side here. Don't actually change the numbers in the problem. Just off to the side, flip them, okay? This is not a fraction. I'm not talking about flipping a fraction. I'm just flipping the numbers over there. All right? And then what you do is you change the sign of just one of them, not both of them. So let me say it again. You flip the numbers off to the side, and then you change the sign of one of them. Flip the numbers, change the sign of one of them. I'll go ahead and change the sign of this one, but if you had changed the sign of the 12, that would have been okay as well. Just don't change the sign of both of them. That won't work. And then what ends up happening, you guys, is that if I multiply negative 8 times 12, that's equal to negative 96. If I multiply this 12 right here by 8, that's equal to positive 96. And so you're going to end up with negative 96 and positive 96 on the next step right here. Those are going to cancel, aren't they? Okay. Those are going to cancel right there. But remember, you guys, you have to multiply the entire equation by the numbers that you're multiplying by. You can't just multiply these terms only, just like I showed you in the last problem here. So what we do is we multiply the side that has two terms on it. We put a bracket around it, multiply that by the numbers that I picked, negative 8 for the first equation and 12 for the second one. Okay, that's why I flipped the numbers. The negative 8 now goes with the first equation, the 12 goes with the second one. You have to do it that way. You can't put the negative 8 and 12 in a different equation. All right, you have to multiply negative 8 by the first one and 12 by the second one. All right. And so we distribute the negative 8 and the 12 through the first through the left sides of the equation here. The point is, though, is that you multiply, just like I did with the negative 3 over here, you guys. You multiply the negative 8 all the way through the first equation, and you multiply the 12 all the way through the second one. Two terms on the left, one term on the right. Okay, so let's do that carefully here. Negative 8 gets distributed to both of these terms, and we get negative 96x, which I already wrote down. And then negative 8 distributed to negative 2y is going to be plus 16y. Don't forget the plus, because you got to have a plus or minus in between the answers when you distribute through this bracket. Okay, bring down the equal sign from the first equation there. On the other side of that equal sign, you got negative 24. Okay, so this equation right here becomes this one. That's what I'm doing. By multiplying by negative 8, it becomes this one right here. And then when I multiply this equation right here by 12, it becomes this one. All right, so let's do it carefully here. 12 distributed to 8x becomes 96x. I already have that written down. 12 distributed to minus 5y is going to be negative 60y. Bring down the equal sign. Negative 9 times 12 is negative 108. And then what did I do on the last problem after I multiplied by one or both equations? I then added the equations together. How do we do that again? We combine like terms on the left side of the equal sign, and we combine like terms on the right-hand side. Let's do that carefully here. What we do is when we combine like terms here, these cancel because they're opposite. Make sure, you guys, that these are not the same sign. That's a common mistake that students make sometimes. All right, these have to be opposite signs of each other. All right, so don't make it 96 and 96. That won't cancel. Got to be opposites. Because they're opposites, they cancel. And then 16 minus 60, you can put that in your calculator. That will be negative 44 with the y there, as it like terms combine. And then here, if you put that in your calculator, negative 24 plus negative 108, that is negative 132. And then, just like in the last problem, you've now created a one variable equation after you add the equations together. So then we solve that equation. It's another one of those things where you just have to divide out here for the same reason as before. And these numbers do divide evenly here, thankfully. Not that they always have to, okay? They usually will, though, in these problems. And a negative 132 divided by negative 44 in your calculator will be equal to positive 3. And so just like in the last problem, after you figure out what one of the variables is equal to, it doesn't always have to be x first, okay? In this case, it's y first. But whichever variable you figured out, you then want to, in the last step of the problem, you want to go back to one of the original equations, or any equation that has both variables in it. It has to have both variables, like I said. Plug the y equal to 3 into it, and then solve for the other variable that you haven't solved for yet. In this case, we haven't solved for x yet, so we're going to solve for that now. So I'll go ahead and pick... just to be different, I'll pick the second equation here. And so remember, I have to plug in the 3 into the y, since it's y that's equal to 3 and not the x. It's x that I want to solve for, though, now. And remember, you guys, I've mentioned this a few times before, but it couldn't hurt to say it again because it can be kind of tricky sometimes. When you have the second term of a polynomial on one side of an equation, all right, the second term, not the first term, but the second term, you got a minus there, it's negative. Remember that this is 8x plus negative 5y. So if I plug the 3 into that term, that's going to be 8x plus negative 5 times 3. And like I said in the last problem, figure out what this term is equal to first, but remember it's going to be 8x plus whatever that's equal to. So this is going to be 8x plus negative 15, isn't it? Negative 5 times 3 is negative 15. But 8x plus a negative, plus negative 15, is the same thing as 8x minus 15. All right? But if that had ended up being positive 15, you'd have to put the plus there. That's the key thing that I always want people to remember. All right, because of the fact that it's plus negative 5 times whatever you plug in. All right, that's what this means up here, plus negative 5 times whatever you plug in. Sometimes you're going to have to put that plus there if it ends up being a positive number here after you multiply negative 5 times this, okay? And so can't emphasize that enough. That's a tricky one sometimes. We then solve this equation by moving the 15 over with the negative 9. So that I have a variable term on one side and a single constant term on the other. This is the division step. And when you get a fraction answer, unless I indicate otherwise, like I've said before, just put it in lowest terms, and that'll be fine. Okay? I never said you had to give a decimal answer or anything like that, or any other type of format of numbers. Okay? Usually, when you get a fraction answer, like I said, where you don't have any variables, you just got two single numbers, one on the top, one on the bottom. Just put it in lowest terms, okay? And that's usually fine. And so that reduces down to 3/4. And so our final answer is, remember the x always comes first, make it into an ordered pair. All right. The only time that you don't have an ordered pair is when? It's when the variables disappear. When you're solving these systems, that's the only time that you're not going to get this ordered pair answer. Okay. Speaking of when the variables disappear, let's look at the next one here. It is going to here. But let's pretend like we don't know that that's going to happen, because I'm not expecting you to know that at the beginning of the problem. You just need to know what to do once the variables do disappear. We have the x's and y's on the same side and the constants on the other, so we're good there. We don't have to do the first step like we did in the last problem where I had to move over the y term on that first step. So then we do that step where we look at the x's and we say, oh, negative 4 is smaller than the 12. What could I multiply the negative 4 by so that it'll be the opposite of 12, which would be negative 12? Well, isn't it true that I can multiply negative 4 times 3? Wouldn't that be equal to negative 12? And then it would be the opposite of 12x down here. And so that will work just fine. You don't have to multiply by a fraction. You could just multiply by the 3. All right. You could also do that with y. Okay. Just because I said to look at x first, that doesn't mean you always have to do that. You could have looked at the y first and said, oh, I'll multiply something by the y instead. As long as it doesn't require you to multiply by a fraction, you could do the y. That's fine. But I just looked at the x first here. It will work. I do see here that if I multiply by 3, I will get negative 12x. All right, bringing this down. But so let's finish it off here. Remember, you got to multiply the entire equation like we did in the previous couple of problems. All right, put the bracket around the side that has the 2 terms. Distribute it through that bracket. You can see I did that here. Bring the equal sign straight down. And then 13 times 3 is 39. Then the other equation stays the same because it has what you want. You want it to be opposite. And so since this is negative 12, there's no use in changing this 12 right here. 12 is exactly what you want if the other equation has negative 12x, right? But something unusual happens here as we get ready to move on to the next step here where we add the equations together. And that is the fact that sometimes when you're in the process of making x's opposite of each other, sometimes the other variable also is opposite. Okay, that happens sometimes. But what happens then when you add the equations together in a situation like that? What happens is that everything cancels on the variable side of the equal sign. All right, these cancel. But these ones do too. And what happens when you are adding a couple of polynomials together and all the terms cancel out, you guys? We've seen this before. That's where the whole thing is equal to 0. Okay? It's equal to 0 when you combine like terms and everything cancels out. All right? It's not equal to 1. We're not canceling above and below a fraction, okay? It is... because we're just combining like terms, this becomes 0x and this becomes 0y, and so it all adds up to 0. But what's the other side equal to? Remember, you got to add that side together as well. That's equal to 34, isn't it? 39 plus negative 5. What did we say, though, in the last video about when the variables disappear, which you can clearly see there's no variable here, right? Okay. Because of the fact that the variables disappear, because it's just equal to 0 on this side, there's no variables. Because the variables disappear, we're either going to get that situation with the fancy looking brackets here, or the situation where you say no solution. Okay, this is the one where it's no solution because why? Because, and this is just a reminder from the last video here, when the variable terms cancel out and the resulting statement is false, such as this one here, 0 and 34 are not equal to each other, then there would be what? No solution. So that's all you got to say. You don't need to do any more work. Okay. If it had been 0 equal to 0 or 34 equal to 34, one of those types of things, okay, like in the last video here, where it was a true statement and the variables canceled out before that, then you would do this type of thing, okay? And you do it in exactly the same way we did in the last video. But if it's false and the variables have canceled out before that, then you say no solution. Okay, so that is the elimination method, you guys. Let's go ahead and take a look at the second page here. There's 3 more equations. Just a reminder, remember you need to put the y on the same side as the x here, just like we did in problem B. And then otherwise, these problems are pretty similar to what we just did, so go ahead and give them a try and hit the play button and we'll look at those answers. Okay, so let's take a look at number 1 on the second page here in section 5.3, and you can see here that the x's and y's are on the same side. They're lined up. The terms that don't have the variable in are on the other side. So we're good there. That's the first step, is to confirm that, to check that. So then what I do is I look at either x or y. I usually look at x first, and I say, okay, 2 is smaller than 6, so could I make the 2 so that it's equal to negative 6, so that it'll be the opposite of 6? You can by multiplying by negative 3. Again, you could have done the y also. I'm not saying you couldn't have done that. Your answer will look a little different at first. The steps will look a little different. But the final answer, if you did it correctly, doing all the same things we're doing, it should come out the same. It should come out the same. If it doesn't, let me know. Send me a message. Send me a picture of your work. I'll be glad to help you figure out what went wrong. Okay, I'm sure we'll be able to figure it out. All right, so, but I'm going to multiply by negative 3 on the first equation, then add that to the second equation, which will stay the same, and it'll look like this right here. Okay, so the first equation becomes this right here. The second equation stays the same. Okay, so you can see I distributed the negative 3 through this whole thing here. I didn't write down the bracket thing this time. I just did it in my head. But just like we talked about before, you do negative 3 times both sides of the equation here. Okay. So again, you don't have to write this down here. You can do it in your head as well, just as long as you know that it's supposed to be done like this. You distribute the negative 3 on the side that has more than one term with the bracket put around those two terms there, and then you just multiply these together. And that gives you this equation here. Okay. The other equation stays the same because we want these to be opposites of each other, so we don't want that second equation to change. Otherwise, they won't be opposites anymore. We then add the equations together. That means to combine like terms on the left, combine like terms on the right, and we get the x's canceling here because they're opposites, and that gives me 5y right there with no x's, and then we get 30 right here. So then we solve that resulting one variable equation since one of the variables canceled out or eliminated. That's why they call this the elimination method. You're eliminating one of the variables. All right, so you have a one variable equation left. And then we solve that resulting equation by dividing out the 5, and you get y equal to 6, right? Okay. Then we now need to solve for the other variable. Remember, you got to have, unless it's one of those problems where the variables disappear, you need to have both an x and a y in your answer. Not just one of those variables, but both. Okay, so since I have y, the answer for y, I got y by itself, I now need to get x by itself and get that answer for x. And you do that in the elimination method by plugging it into either or any equation that has both variables in it. I usually pick one of the original ones. What did I pick here? I picked the first equation there. So I plugged the 6 in right there. Okay, plug the 6 into there. So we have 2x plus negative 1 times 6. All right. That's the same thing as 2x minus 6. All right. Same thing as this right here. In fact, I can go and erase that bracket there just because it comes out that way. But yeah, it's negative 1 times 6. Remember, when you have a minus in front of a term, but there's no number there in front of the variable, that means that the coefficient is negative 1. So negative 1 times 6 is negative 6, and that's why it's minus 6 here. All right. We then solve. But again, remember, you got to figure out what that term is equal to that you plugged into first. That's why I said negative 1 times 6. Now you go through the normal solving process here. Okay. Moving over the 6 with the 4. And then dividing out by 2. And you get x equal to 5. Okay. So that is problem number 1. Number 2. Remember, again, in number 2, you got to move over the y with the x right there, so that the x's and y's are on the same side and they line up and everything. So I did that by what? I did that by subtracting the y over, okay, to the other side, just like I did in problem B. All right, if you have a polynomial on both sides of the equation with no parentheses that need to be cleared out, in that case, if you want to move a term over, you add or subtract it over. You don't divide both sides by y, you add or subtract it over. Now that everything's lined up, x's, y's, equal signs, the constant terms are all lined up, now you do that same thing again. And I decided to be different this time, and I decided to look at the y's first, even though I usually look at the x's first. And so I look at 5 and -1, you guys. 5 and -1. 5 is the bigger number. And so you look at the -1 and you say to yourself, okay, what could I multiply -1 by so that it'll be equal to 5? Well, wouldn't you multiply by -5 in order to get it equal to 5? That'll work, right? And so that's why I said right here, oh, wait, hold on. I apologize. I made a mistake there. We want it to be equal to -5, not 5, because we want it to be the opposite of this one, not the same, right? Okay, and so, excuse me there. So we want it to be equal to -5, so it'll be the opposite of this one. And so that's why we need to multiply by a +5. -1 times 5 would give you the opposite number that you need, opposite of this one up here, and that would be -5, okay, because you want -5, so that'll be the opposite of that. All right, so since this is 5, you want this to be -5. Multiplying by this number here will make that happen, because currently you have -1 right there, and so multiplying by +5 will make it what you want it to be. So if I multiply the second equation by, as you can see here, E2 means the second equation. You don't have to write this down here. This is just, again, me communicating with you what I'm doing. But you're multiplying the second equation by 5, all right? And then you are going to add it to the first one, which will stay the same. So multiplying the second one by 5 will give you this right here, all right? Again, you distribute the 5 to the side that has 2 terms on it. You distribute the 5 through there as if there's a bracket there. You don't have to write that down like I said, but you distribute it in the same way that you would if there was a bracket here. So you get 5x minus 5y, and then you just multiply the side that has only one term. You just multiply that by 5 also, and so that gives you the 15. So once I do the multiplication step, I then add the equations together, okay, and I get the y's canceling, thus giving me a one variable equation here, 8x equal to 16. Again, the goal is to eliminate at least one variable there so that you have a one variable equation that you can solve on the next step. 8x equal to 16, that's a one variable equation. So now I have what? Now I have to divide by 8 there. That gives me x equal to 2. I then take the x equal to 2, since I now have one of the answers. I then plug it back into any equation that has both variables in it so that I can figure out what the other variable is. I went ahead and picked this one right here. Again, it doesn't have to be one of the original equations as long as it has both variables in it. So I picked this one. All right. Figure out what that term is equal to that you plugged into first. 1 times 2 is 2. All right. Let me write that down over here. For some reason, I didn't write that equation down first, okay, when I wrote this out. So then that's why I said minus 2 on each side here. I'll just do it off to the side here. It looks better this way. Again, I'm not sure why I did that. And you end up with negative y equal to 1. It's the same as this here. It's just written better over here. And so then we get negative y equal to 1, but you still got to do what? You still got to divide out. You still got to divide by negative 1 to get y completely by itself, right? And so divided by negative 1, we get y equal to negative 1. Okay, 1 divided by negative 1. And so we end up with x equal to 2 and y equal to negative 1. Final answer then is 2 and negative 1 paired up. Okay? So that is problem number 2. And finally, problem number 3. Okay, we need to, what here? We need to realize that the x's, if I multiply 2 by something, I'd have to multiply by a fraction in order to make it the opposite of 3. Okay, we don't want to do fractions if we can avoid it, right? Same thing here, 4 is smaller than 5, so I say to myself, if I multiply 4 by something to get it equal to -5, so it'll be the opposite of this, I'd have to multiply by a fraction. Don't want to do that. So this is one of those problems, just like problem, which one was that on the front there? It was problem B, okay, on the front, where if you can't avoid fractions by just multiplying by one of the equations, and you've tried both variables, neither one of them work without doing fractions, then you do that thing that I taught you where you flip, and you could do either x or y. So here I did x, I flipped the 2 and the 3 so that the 2 is up here and the 3 is down here, but then I changed the sign of one of them. I decided to change the sign of this one. Okay, so for 3 and 2, what I did was I flipped it so that the 2 is on top and the 3 is on the bottom, and then I changed the sign of one of them. That's why it says -2 and 3 right here. If you decided to do the y's, that's okay. Let's try that just for practice here. All right, if I flip the 4 and the 5, it looks like this, right? It'd be this right here, wouldn't it? And then I changed the sign of one of them. Okay, and in fact, I wrote that down off to the side here, but that is what you would do if you decided to eliminate the y's and get the y's to cancel out. Either way will work. Again, your steps will look a little different than mine if you chose to do the y's instead of eliminating the x's, but in the end, your answer will still be the same. Okay, I guarantee it, as long as all your steps are calculated correctly, of course. All right, but I went ahead and I did the x's here, so, excuse me, I did the -2 and the 3. So as we talked about, you distribute the -2 to all of the terms, all right, just like we've been doing, keeping the equal sign in the same place. All right, same thing with the 3. Distribute that to all 3 terms, all right, keeping the equal sign in the same place, and you end up with these 2 equations right here. Okay, -6x minus 8y equal to -18, and +6x plus 15y equal to 39. All right, then when you add the equations together, you get the x's canceling out, and you end up with 7y equal to 21. Okay? Then we solve that equation just like we've been doing all throughout this section. All right, divide out, and you get y equal to 3. All right, we're halfway there, right? We figured out what one of the variables is equal to. We got one of the variables by itself, in other words, and then we now need to solve for the other variable. Pick any equation that has both variables in it, plug the y equal to 3 into it, and then solve for the other variable, which would be x in this case. So I picked the second equation up here, just to pick something. I plugged the 3 into that. Again, I plugged it into the y. Don't plug it into the x because it's y that's equal to 3, not x. And then, so I plugged it in, figured out what the term is equal to. Okay, so positive 5 times 3 is 15. Remember, this is plus, okay? So you have to say plus 15. Don't just say 15. All right, so this is plus 5 times 3. Just like earlier when we had minus here, it would be plus negative, and I can't remember what that number was, but I'll find it here for you. Just to give you an example, yeah, it was problem B in the front. When it's minus on that second term there on the left, all right, you say plus -5 times whatever you plug in. But when it's plus, when it already is plus in front of that second term, then you just say plus 5 times 3. But it's still, because of the plus, you still got to have a plus here in front of the answer, unless it's negative, and then you'd have plus -15, and then it would change to -15. But either way, you're adding, all right? So if this had been negative 15, you'd have minus 15 because that's the same thing as plus negative 15. But because it was positive 15, the plus stays as plus. All right. All right, so you then subtract the 15 over. You get negative 2, and then you divide out, and you get x equal to negative 1. Oh, sorry, that came off the screen there. Sorry. There we go. So divide out by negative 2 right there on this step, and you get x equal to negative 1. So now we have gotten both x and y by themselves. We solved for both of those. And so our final answer is negative 1, 3. Okay? And so that is the elimination method. All right? So let me know if you have any questions about the elimination method and also the substitution method. Remember, you need to remember that on the test there will be at least one question where you have to use the elimination method and at least one question where you have to use the substitution method. Okay? The directions will make that clear. So make sure you know how to do both methods, all right, so that you'll be ready for both of them. All right? But otherwise, let me know if you have any questions about anything else as well. You have a great day otherwise, and take care, and we'll see you back for section 3.6 in the next video.